All right, in this lesson, let's talk about defining what deep learning is. But before we can define what deep learning is, we need a little bit of vernacular, all right? So here is an Excel spreadsheet. And by and large, if you can get your data into the form of an Excel spreadsheet, then we can do deep learning on it. So if you're coming from the relational world, which I was, the nomenclature is a little tricky. For example, they don't call rows rows. You and I would call that a row. Well, because that's what it is in database speak. They call it an observation. All right. So when you hear observation, think row. Down here at the bottom, we have this thing called a target variable. Well, what's that? It's this column here, well, this entire column, that we are trying to predict. This is our target variable. We're trying to predict whether an individual will buy a bike, 1, or won't buy a bike, 0. And we're trying to do it with all that data. All that data, right, in the yellow is called training data. Over here, these columns, right, are called features. Right? Not all of them together, each one. So the marital status itself is a feature, gender is a feature. All right, you get the idea. All right, let's talk about a neural network. So if you were to type into Google neural network, this thing right here is what you'd see. This is a very shallow, actually one layer, because we have one layer here, neural network. So what is all this stuff? All right, so on this side we have the input, right? Well, what is an input? Input is simply data, right? You'll see this a lot. X1, X2, X3. All right, so the X on any input simply means data, right? We're putting some data in here. So this would be over here, we have X1, right? This would be X2, and this would be X3. It is simply data. All right, so what kind of data? Well, why do I have this 35 here? Male, 49,000. What are these? So you and I speak text. Machines don't speak text. They speak numbers. So we need to get our data into a numerical format. Here we have it into a numerical format. However, it's not normalized, and we'll talk about normalized later, but this next step here normalizes it, right? Here we have text, right? We can't, no can do, right? So we've got to turn that text into a number. Well, male or female, right? Male is equal to 1, so there's our 1. Female is equal to, so the sad looking F, isn't it? 0. Right? How about 49,000? Right? That's a number, but it's too large. So what we need to do is get our data in a certain range. And again, we'll talk about why later, but for now, let's just go with it needs to be in a range, and this is outside the range. Right? So we're going to tone this thing down, this range, to a 4.9. So that's what all this is. So all this is, right, this whole thing, we were to circle this. Ooh, that is a horrific circle. All right, that's our input. Okay, that's our data. So we need to input some data into our neural network. This thing here, he does the work. Right? This is, all right, I love this word. This is called a perceptron. I mean, it sounds like Optimus Prime, doesn't it? These are perceptrons. Another name for these is artificial neuron. Right? Those two are synonymous. The output, well, the output is all of this, all these numbers calculated and added up to make a prediction. All right, so here it says we've got an output. Again, it's numerical. We'll call it a 1. And over here on our output, on this side, 1. So if both sides say, we think this person is a buyer, then we're going to output a 1. And we're going to say that this person is indeed a bike buyer. 0, not a bike buyer. 1, bike buyer. This is a neural network, right? It's a shallow neural network because we only have one hidden layer. So that's what these perceptrons, or these artificial neurons, are. We only have one, but in reality, we're going to have a whole lot. So 1 is not really deep learning. Now, this is kind of weird. So if we only have one hidden layer, right, a lot of people would say this isn't a deep neural network. If we have 2, right, let's say we have going in, and now we've got it going there. Let's say this is also a hidden layer that goes the whole way up. That's all we need are 2. We do have, right, a deep neural network, in which case we are practicing deep learning. Actually, think of this whole thing, right? The whole process is one big math equation, because that really is what it is, right? We're putting data in here. It's getting crunched up here in this middle. Data gets crunched at all these different levels. Different perceptrons do different crunching, and then these guys get together and say, you know what do we think the output's going to be? Is that person going to buy a bike? Is it not? And then we get a final output. So many would say that deep learning can be defined as the presence of 2 or more hidden layers. Right? And that's what these things are up here. These are hidden layers. All right?